This is a problem of dependent motion system, Mass-Pulley system. The Mass-Pulley system is designed to consist of log A, block B, and collar D as shown in the figure. Given that both log A and collar D move with a constant acceleration of 0.2 g downward, where g is 9.81 meter per second square, and that the system starts from rest, determine A, the acceleration of block B at the instant, B, the corresponding acceleration of collar D relative to block B, and C, the velocity of log A after it has displaced 10 cm, the corresponding time, and the displacement of block B. This is the diagram of the problem. We create a datum, a reference line at this level passing through the center of 3 pulleys. Before we answer the first question, let's make some assumptions. Firstly, we assume that the cable or rope does not extend or shrink. It is not elastic. The cable or rope remains taut. The size of the pulleys is negligible, including the mass of the pulley. We assume it is negligible. No friction at the pulleys. And we take the positive I direction downward. In the absence of vector notation, positive values mean downward and negative values mean upward. First, let's obtain the length of the cable without including of the fixed length. If we see this diagram, the length of the cable consisting of XA 2 times XD and XB. It is constant. By differentiating this equation with respect to time, we can obtain the equation for velocities. X dot A plus 2x dot D plus x dot B equals to 0. X dot in this case is the velocity. So we have velocity A plus 2 velocity D plus velocity B equals 0. And if we differentiate another time this equation of velocities, we are going to have the equation for acceleration. We have x double dot A plus 2x double dot D plus x double dot B equals 0. And x double dot in this case is acceleration. So we have AA plus 2AD plus AB equals 0. One information that we have from the problem is that we have the acceleration of log A and collar D constant equal to 0.2 g. So if we replace AA with 0.2 g and also AD with 0.2 g, the remaining variables in the equation is AB. Hence, we can obtain the value of AB. AB equal to negative 0.6 g. The acceleration of AB is negative 5.89 meter per second square. We can also write this acceleration in terms of vector. Vector AB equal to negative 5.89 I meter per second square. You may also write like this. AB equals to 5.89 meter per second square with an arrow upward, which means to the negative x direction. Question B. The corresponding acceleration of collar D relative to block D. The vector of acceleration of collar D relative to block D, ADB, equals to AD minus AB in vector. AD is 0.2 g directed downward, 0.2 g I, 1.96 I meter per second square. AB, from what we obtained previously, is negative 5.89 I meter per second square. From these two values, we can calculate the vector A of D relative to B. It is 7.85 I meter per second square. Or you may write AD relative to B equals 7.85 meter per second squared with an arrow downward, which is the positive direction. Question C. The velocity of log A after it has displaced 10 centimeter, the corresponding time, and the displacement of block B. For this problem, we can try to calculate the time first and then the velocity of log A afterwards. It is stated in the problem that log A has a constant acceleration of 0.2 g downward. A of log A equal to 0.2 g, and that is equals to differential of VA with respect to time, dVA over dt. Integrating this, we obtain VA equal to 0.2 gt plus VA naught. And according to the problem, the system starts from rest. So we have VA naught equal to 0. Hence, we have the expression of VA is 0.2 gt. VA is differential of position, dxa over dt. Integrating that, we obtain xa equal to 0.1 gt squared plus xa naught. Or we can write xa minus xa naught equal to 0.1 gt squared. Xa minus xa naught is the displacement. If xa minus xa naught equal to 0.1 meter, it is equal to 0.1 gt squared. From here, we obtain the value of t. T equals 0.32 seconds. So we obtain the time required for log A to move by 10 centimeters. We have the equation of velocity A, which is 0.2 gt, and then we have the time. So we just replace the t in the equation with 0.32 seconds. And we obtain the velocity of log A equals 0.63 meter per second. To calculate the displacement of block B, we have AB, the acceleration, equal to negative 5.89 meter per second squared, which is dVB over dt. Integrating that, we have VB equals to negative 589 t plus VB naught meter per second. However, we have VB naught equal to 0. Why? Because the system starts from right. So we have VB equal to negative 5.89 t meter per second. VB is equal to dxB over dt. Integrating that equation, we obtain the equation for the position of block B, or the displacement xB minus xB naught. Putting the value t equal to 0.32 seconds, we obtain the displacement of block B equal to negative 0.30 meters. We can write the displacement is 0.30 meters upward.